Hey you all, hope you guys are doing well. This is our first main tutorial for class, basically my first little lecture here that I'm going to do for Monday. I've decided I'm going to do 3 a week instead of 2 a week, and they're just going to be way shorter. So the idea is that this will be like about 15 minutes, and then on Wednesday I'll do another one that's 15 minutes, and then on Friday similarly 15 minutes. And then there'll be short quizzes for you to take on Blackboard that cover all these topics, okay? This week, just so you are aware, we're covering synthesizers and synthesis. We've talked a lot about audio and stuff like that, and here's talking about all the synthesizers in Logic and just general synthesizer knowledge, because it's the same on every platform you go to, and for most synthesizers, they have the same parameters available, okay? So just to get started here, sound synthesis is the act of creating a sound from scratch using electronic hardware or software instrument, okay, or in software instruments. Synthesis of sounds is commonly used to do two main things for music. To generate sounds unique to electronics, right? This is the primary reason, really, to generate sounds that are impossible to create on an acoustic instrument. And then the second one, to recreate or model the sounds of a real acoustic instrument or real world sound. So there is a fair amount of synthesis, and this is where Fourier's theorem comes in, right? The idea that you can recreate a sound of an acoustic sound by building it up from its principal components, right? Its principal sine waves or what have you. Okay? So a synthesizer, again, is then an electronic instrument, an electronic musical instrument that is designed to generate audio signals. And that's what all of the synthesizers in Logic do, is that they generate audio signals, they generate different sounds. The types of synthesizers, and there are others. These are the 4 most common types of synthesizers these days. And 3 of them have been around for a long time. The first one is additive synthesis, which is pretty simple. We'll talk about them in general in a sec. Subtractive synthesis. FM synthesis, which is FM frequency modulation. I talked about this at the beginning of the semester. You might remember me playing 80s music and talking about the DX7, the Yamaha keyboard that used FM synthesis to create sounds. And the last one, called wavetable synthesis. This is really popular right now, and these days really came about with a couple of synthesizers that were invented in the mid, I can't remember when Serum came around, maybe 2014 or roughly, but these synthesizers have become very popular, and they're all types. I'll get into them in a second. So the first thing is additive synthesis. Additive synthesis is the process of creating a synthesizer by combining many simple waveforms together to create a more complex wave, right? And I talked about this one time. I was talking about this in a class. Actually, I can show you, because in Max, I had this example. Well, I use this all the time, but a perfect example of this is additive synthesis, which is not that file. Oh, where is the file? Yeah, actually, let me go in here. Max projects. There's one in my vocoder. So this is a perfect example of an additive synthesizer. You can see right here, these are my sound generators, these saw waves and rectangle waves. There's another cycle. So all these little blue, what I've made blue now, those are my wave sounds. And I'm basically adding them together, putting them all together to create a single sound that goes out this output, right? So this is an additive synthesizer. I'm adding together a saw wave, a cycle, which is a sine wave, another saw wave, another sine wave, a saw wave again, and a rectangle, which is similar to a square wave. So this is a perfect example of an additive synthesizer. And additive synthesis is kind of one of the main themes here. It's still a very common use for synthesizers. The second one is called subtractive synthesis. And that's a synthesizer or a synthesis method where the quality of a sound is altered by removing frequencies of a sound source through filtering. So the idea is that you usually have a wide spectrum sound and then you filter out most of the sound to create a unique sound by subtracting frequencies from it, taking them away. Okay? FM synthesis then is called frequency modulation synthesis, and don't worry about this too much because it's confusing, but is achieved by taking the frequency of a waveform, which is called the carrier, and modulating it with a second waveform, the modulator. The frequency of the carrier wave is modified by the amplitude and frequency of the modulator. So just think about taking two waveforms together in a way, multiplying them together, and then coming up with something more complex. And that's what FM does. The last one is wavetable synthesis, okay? And this again is a kind of a brand new way of synthesizing, and it's very popular in electronic dance music and other things. And this picture here shows you Serum. It's a synthesizer that creates sounds by cycling through a table of oscillators or waveforms, okay? And you can see that in this picture here, there's actually all these waveforms, and let me show you in Logic, because I can pull up Serum pretty easily. And it'll make more sense if I show you that oscillation. So if I go to spectral, pick one of these crazy ones. If you can see, if I do this, see how I'm cycling through all these different waveform types. So if I play a sound. So this is a wavetable synthesizer. It uses multiple waveforms and cycling through them to create unique sounds, okay? Very popular with dubstep and stuff like that, a lot of electronic music these days. Okay, so going back to here, so those are the four types of synthesis again, right? Going back here, additive synthesis, subtractive synthesis, FM synthesizers, and wavetable synthesis. And today we're really just talking about additive synthesizers, and also we're really just talking about the basic concepts of all synthesizers in these programs. So for our sake, there are really three principal components for every synthesizer, okay? The first one is the sound oscillators, or the sound sources, the actual things that are making sound. In this case, it's going to be an oscillator, right? Something that moves back and forth. A sine wave, a square wave, a rectangle, something that makes sound, all right? Then the sound is usually sent through filters of some kind. So filters are really common. Some way of changing the sound by removing or emphasizing certain frequency bands, right? We know what filters do, like band pass filters, low pass filters, high pass filters, and so forth. The last thing is the amp envelope, which is really important, but it's basically how the sound is delivered by the instrument in a way. How the sound is delivered in terms of its volume, which we'll get into on Wednesday and Friday, okay? Today, we're just talking about sound sources and oscillators once I get into this a little bit. So, but I do want to show you, I'm now going to show you a bunch of different synthesizers in Logic and show you how all of these synthesizers have these three main components, right? They all have sound sources, oscillators. They all have filtering. They all have some sort of amp envelope to modify the sound's output, okay? So the first one is what's called retro synth. So this is the one that's supposed to emulate kind of old school electronics from the 70s. And you can see here by my little boxes, this is the oscillator section, this is the section of the synthesizer that creates the sounds, okay? Then we move on to the filter, which is here right next to it. There's also a section called modulation that we're going to get into next week, or maybe later in the week, I'm not sure yet, but and that we'll get into as well. But right now we're just sticking with these three components. So the oscillators, the filter, and then the amp envelope, which is very obvious in this synth, which I really like. But this is the cleanest, kind of simplest synth that we have in Logic. So let's talk about now ES1, which is another synthesizer. Here you can see it written right across the front here. We have the oscillators. There are two oscillators. You can see oscillator here and another oscillator here. Then the filter is in the center, okay? And you can see I can change actually things like the type of filter, the cutoff frequency is here. The drive increases the volume of the sound that's not being filtered away. And then, yeah, there's all kinds of stuff I can change with it, all right? Then the last part is the amplification. So the amplifier is the ADSR, which we're going to get to talking about here on Wednesday. The shape of this sound being delivered out through the sound, right? Out the output. Okay? So, and then again, so here's ES2, which is a monster in terms of trying to sort out how it works. I like the synth a lot, but it's still very complicated to me, and I really don't like the GUI. I think it's hard to figure out. But first of all, we have on the left, again, the oscillators, right? There are three oscillators in this case, number 1, number 2, and number 3. Then we have the filter in the center here, and this is a complex filter. I can do all kinds of crazy stuff with this thing. And then the amplitude output. So this is the amp out. It's also related to this section down here, but I just wanted to highlight this bit. The volume control is here. I can add some effects on the output of the sound, but that's basically what happens in ES2, okay? Here's Logic's Alchemy synthesizer. And you can see right here, these are the modulating sources. In Alchemy, there are 4 of them, A, B, C, and D. And you can see here, these are little pull down menus where I can pull down this waveform, pull down this waveform, pull down the waveforms, okay? And then, yeah, and that's where the sources come from. Then there's the filter next to it, okay? And the filter is about this is the main filter for the main sound itself. And the last bit here is the master. This is the main output or the amp envelope sound. The amp envelope in Alchemy is also related to this area here, which is the ADSR, which we'll talk about later. But anyways, you get the idea. Notice that so far too, every synth we've looked at has been linear in a way this direction, right? The sources are on the left, the filter's in the middle, the master, the main output amp is on the right, okay? The only exception to this was this one, which kind of has the oscillator, the filter, and then the amp is down here on the bottom left, right? Or the bottom right, sorry, okay? So, and then going on, the last one, this is actually not a Logic plugin, but it's a very popular synthesizer called Serum. And it is a, very, very popular. This synthesizer made this company millions of dollars because they sold buckets of it. I love it, actually. It's really cool. But you can see here, my main oscillators are here in the center. Okay, I have oscillator A, and oscillator B. And this is, again, a wavetable synthesizer. Then I have my filter on the left, on the right side here. Okay. And then actually my envelope and output is here. So just getting a sense of, this is my what's called ADSR again. It's the shape of the sound as it goes out the outputs, okay? So, and those are all just, this one's not native to Logic, but the others are. But the general sense again is that we have these 3 main sections of the sound, right? And these 3 sections of the sound are really what generate the sound and define it as it is in every synthesizer that we have. Okay. The last thing I want to talk about is sound sources and oscillators. So these are just some waveforms that are possible in Serum, but let's take a look at some others. You can see here the sound sources here are come up. So the sound sources again is the first section, right? So the oscillator, this is retro synth. It has two waveform possibilities, and I can actually mix these together. So, and this is ES2, which has three possibilities, three waveforms at once. And then my mixer is right here in the middle, this little three-pronged mixer, okay? So when we talk about oscillators, the most important parts of oscillators are all these things listed here. First of all, these selectable waveforms, okay? Usually there's 2 to 4 oscillators in a synth. It just depends on the synthesizer. Like ES2 has 3 of them. Alchemy has 4. RetroSynth has 2. Serum has 2. Massive is another big wavetable synth. I can't remember how, I think it has 4 oscillators, okay? Then the next is the oscillator levels, and that's the main volume of the oscillators, usually in a knob or a slider. And then I can change the mix and the balance of those oscillators sometimes if there's a mixer, okay? The next thing is the tuning of the oscillators. And in this case, we have coarse tuning, which is basically changing the note, the sound of the note by a half step, okay? So basically that's moving from a white note to a black note on the piano. It's the smallest interval between the piano keys is what's called a half step. And that's what the coarse tune can do. In fact, over here, you can see I can change the coarse tune. Well, we'll get to it here. But anyways, I can change it. Then there's the fine tuning. There are 50 increments usually per semitone in fine tuning. This is where I can detune things a little bit, make them kind of weird, do all sorts of cool stuff. Then the last bit here is the oscillator panning, okay? And the oscillator panning is obviously setting the left and right placement of each oscillator, okay? So I think this is my last slide. So this is showing you Alchemy, which is Logic's synth. And you can see I can mix these, first of all, with the volume, okay? And I can set the saw waves here, with the waveforms here. The tuning, this is the coarse tune and the fine tune, I believe. I think I have to just choose the difference between them. I can't remember where it is exactly. But anyways, and then pan is next to it, okay? And if I go into Alchemy and just show you that, let me show you. So let's go to Alchemy here, which is, again, is really Logic's best synthesizer. So you can see here, if I go to click on the saw wave, I can click on this and download. There are hundreds of different sounds that are possible, metallic. It doesn't give me a visualization, but I can choose a different waveform if I want for each oscillator here. I could maybe detune this by semitones, right? I can't remember what this knob does, but I wouldn't worry about it. Anyways, but you can see my volume changes here. So say I want oscillator A to be loud, oscillator B to be quiet, oscillator C to be a little quiet again, and there you go, okay? So anyways, so that's all I want to cover on this lesson, and I will be posting tomorrow an assignment, and I'll email you when that assignment happens. But basically, again, let me just go through this quickly, right? Let's go back to the first slide. On the first slide, we talk about sound synthesis. We talked about the types of synthesizers: additive synthesis, subtractive synthesis, FM synthesis, and wavetable synthesis. The types of synthesizers, again, this is the big thing, right? We've talked about sound sources, the oscillators themselves, and then how they're filtered, and then they go out the amp envelope, okay? The next thing is I just showed you some examples of these, right? Here's the oscillators, the filter, and the output. The oscillators, the filter, and the output. The oscillators, the filter, and the output. And then the types of sound sources. So in this case, the mix with ES2 is with this little triangle. And if I push this little button here all the way over, for instance, let me show you that. If I go to ES2, if I move this all the way up to the corner, then I'm only hearing number 1. If I go to the middle here, I'm hearing none of number 3, but only the middle of 4. So you can see I have this kind of 3-dimensional mixer for the 3 different oscillators, right? And I'm going to get into this some more, and then my coarse tuning is here, right? This is my tuning of the sound. Here's my fine tuning of the sound. Okay? So anyways, so those are the basics. And I will be putting together a quiz, and I will let you know when it comes up. All right?